And the solution is provided on the Leetcode website as well. I'm giving a video explanation. So you can see the problem here on the left. Given an integer array nums of length n and an integer target, find three integers and nums such that the sum is closest to the target. Return the sum of the three integers. You may assume that each input would have exactly one solution. All right, so to start this problem off, declaring or initializing two variables, diff and size. These are integer variables. The diff is going to be set to the maximum possible value of an integer in Java using integer.maxValue. And then the sz integer variable is going to be initialized to the length of the input array, so nums.length. And then we're going to sort that input array nums, calling a function in Java. And then we're going to set this for loop that's going to iterate through the input array, and also it will end if the diff value becomes equal to 0. All right, and then to start it off, we're going to set our low pointer and our high pointer. So you can see kind of like a visual down here I put in the comments for kind of how this plays out, right? So your I value that's initialized in the for loop is going to start like, in the very beginning of the input array. And then your low pointer is going to be I plus 1. So in this case, that's going to be the position where the number is 2. And then the high pointer, which is going to be the length of the array minus 1, which in this case is -4. All right. And then we're going to do a while loop where the condition is while the low pointer is less than the high pointer. So when we get to a point where the low pointer and the high pointer are equal, or they overlap down here, that's when this while loop ends. And then we increment I by 1 and repeat this process until we find our solution. So you can see here, this is where we add up our three values, right? The position of I, the position of the low pointer, the position of the high pointer, they get added up here. And then we do an if statement here where we check to see if the absolute value of the target minus the sum is less than the absolute value of the diff number. And if it is, first of all, it definitely will be in the first run, right? Because we're setting diff to be the maximum possible value of an integer in Java. So to start off, this condition will definitely go through in the very first run. And then the diff is going to be equal to the target minus the sum, or we're going to set diff equal to target minus the sum, right? Each time that it's less than the current absolute value of diff. And then this is our increment decrement condition right here. So if the sum is less than the target, we're going to increment the low pointer. Otherwise, we decrement the high pointer, right? So we just keep going like this until we complete the for loop. And then we will eventually find our solution. And we're going to return that by returning the target minus the difference. And I just threw in some extra print statements in here just to kind of demonstrate where the target and the diff value end up being at the end. And I'm going to run this code just to demonstrate that it works. All right, accepted. You can see that. And the time complexity here is going to be O n squared. And that is due to the inner looping. So you have a while loop instead of a for loop. So it's going to be n squared in runtime. All right. And the space complexity is going to depend on, according to Leetcode, depends on the implementation of the algorithm. So we're just going to say O of n for the space complexity. I'm going to submit. And you see it succeeds. So there you go. That's my quick explanation of the two-pointer solution in Java for the 3sum closest problem. I do recommend also checking out the Wikipedia page for this problem, as it is a common problem in interviews, and also there are different variants of this problem to be aware of and different solutions as well. So definitely look into this one beyond what I explained here. I at least recommend doing that. Thank you.